Hey Bears, this is Miss Madden wanting to go over your lab with you that I left you yesterday on Monday, September 13th. I'm going to go over each step on how to do your calculations, and then on Wednesday we will start an introduction to electron configurations. So please make sure that you have your periodic tables, because you will need those in order to be able to figure out electron configuration. If you're missing any assignments, please take care of those. I can't ask that enough. I will be out for the remainder of the week, and I can't stress enough how much I need your help right now. So please take care of your assignments daily. Don't waste your class time. I'm not giving you any more work than what you need, I'm not giving you any more work than what would require you additional work outside of class. So everything I'm giving you, you should be able to complete during class time. All right. So for today, what I really need for you to do is to complete your lab, and I didn't have a whole lot of people turn those in. So here we go. All right, in your Monday folder was your Beanium isotopes. We had finished off last week talking about isotopes, and I gave you extensive notes on how to calculate average atomic mass. And so this was an extension of that. I'm going to kind of walk you through this. I'm kind of short of breath, so I can't, I'm going to try to read as much as I can. I appreciate your patience. So in this, theoretically, these beans, which you're given pictures here, are supposed to represent isotopes, 3 different isotopes of the same atom. Remember, isotopes are atoms that are of the same element because they have the same number of protons, but their neutrons are different. And so it gives them different masses because their neutrons are not the same. So we're going to just pretend that those beans are representing atoms. All right, and we're going to just skip to number 2. In the data table, describe each isotope clearly, explaining the differences between them. So in this first data table, what you're supposed to do is you see the total number of beans, and some of this is partially already done for you. So if you count all of these, you'll see that there are a total of 16 different beans. 16 beans, some of them are the same, some of them are different. There are 3 different types. So here in these spaces here, you were supposed to count each different type. So isotope 1 is representing the white beans. You can see that there's 1, 2, which is why there's a 2 there. Isotope 2 is representing the kidney beans. Count those, put your total here. Isotope 3, you count the chickpeas or whatever they are, I'm not sure. Count those, total goes here. Pause the video so you can add your totals. Data table 2, you're supposed to give a description. You can see here, isotope 1 is already done for you. The isotope 1 are these white beans, so we put white, that they are the largest. And I used the shapes to try to include somewhat a visual of what they look like. So for isotope 2 and isotope 3, I'd like you to do the same. Give a description. What color are they? Give a description of their size. If you can, use some shapes or some, even if you want to do a drawing, and upload the drawing to each of those, that would be sufficient. But give at least 3 different descriptors of isotope 2 and 3. Pause the video so you can include those. For data table 3, it's pretty much already done for you. You have your totals of each bean representing each isotope, along with a mass that is provided for you for each one of those. So there's really nothing for data table 3 that you need to add. But what you have in data table 3, you're going to need to use for data table 4. So for the first part of data table 4, you're going to calculate your percentages. And honestly, when you do your calculation, it's already going to be, how do I describe? It's already going, you're going to give me your percentage, but the first number that you give me is the number you're actually going to use in the average atomic mass. So for isotope 2, there are 5 total. You're going to divide that by 16 and give your total here. When you multiply that times 100, that is your percentage. So there are 2 answers that you need to give for these 2 boxes. Isotope 3, take your total number of those beans that represent isotope 3, divided by 16, give your total, multiply by 100, and you have your percentage. Pause the video so you can fill in those boxes. All right, for the final last box of data table 4, you're going to take your top numbers. Then I'm talking about these, no, these answers up here, right here, your answer from isotope 2, your answer, their first answer from isotope 3, and they're going to plug them in here. We don't, remember, we can't use a percentage. So even though I'm asking you for the percentages in these boxes, whoops, you're not going to use the percentages. You're going to use the first answer in each of those. You're going to plug them in, multiply them times the mass, and get your answer for both of those. Again, you're using the first answer you get, not your actual percentages, because when we calculate average atomic mass, we are not using percentages. We have to use real numbers. So it's going to be the real number times the mass. Real number times the mass. Get both your answers. Pause the video so you can do that calculation. Once you've completed that final, those final boxes of table 4, you're going to include those in data table 5. Your first isotope is already done. You're going to include your second isotope and your third isotope, and you're going to add them all together for your final total. Your final total will again be placed here, down here at the bottom. And that's all you got to do. It's pretty simple, shouldn't take you too long. Try to give me some good descriptors here in data 2 for your isotope 2 and 3. make sure that your calculations are correct, and you're done with your first lab. Tomorrow, like I said, after you're done with this, if you have any remaining work that needs to be complete, please complete that. Um, I'm trying to grade and keep up with grading as much as possible. Um, Tomorrow, we will begin electron configuration. So please make sure you have a periodic table, as I will be trying to introduce that to you and going through that with you. If you have any questions, please email me. I'm doing my best to try to email. I know I got a lot of emails about this lab today, which is why I went ahead and made a video instead of trying to answer each individual email. I thought maybe this might help you. All right, but please go ahead and email me. And I will see you soon. Thanks, guys.